Complex numbers are numbers that have a real part and an imaginary part. They're involved in the development of many objects you use every day, from your washing machines to the electromagnetic waves your internet relies on. They're also used to model satellite positioning, the behaviors of suspensions on an F1 racing car, and how the suspension bridges would react under different wind conditions. The last example is particularly important to make sure an incident like the collapsing of Tacoma Narrow Bridge does not happen again. The real part of a complex number is just like the most other numbers used so far and can be represented visually on a straight line. But what is the imaginary part? Let's take the number -1 and square root it. What would you get? If you haven't come across complex numbers before, your answer will most likely to be along the lines, this is an impossible operation. In fact, most of your calculators will retain an error, and this is where the imaginary part of the complex number comes in, where the square root of -1 is one imaginary unit written as a little I. Square root of -9 would then become the square root of 9 times by the square root of -1, thus becomes 3 imaginary units. Like real numbers, we can represent complex numbers visually by adding an imaginary axis perpendicular to the real axis. A complex number such as 4 plus 3i can be represented as a vector like this. And this diagram is called an arc diagram. The absolute value of the complex number is the length of the vector, and the argument is the angle between the vector and the real axis. Thus, 4 plus 3i can also be represented in its polar form and its exponential form. Thank you for listening and watching.